Hello everyone. So let us start with the first module of hydrology and irrigation. That is, the first module includes hydrology and precipitation. Okay, so first let us see what is this hydrology. So hydrology is defined as an applied science which mainly deals with the study of water on earth in its various state, and that occurs, that is distribution, circulation through hydrological cycle of precipitation, then runoff, stream flow, infiltration and storage, eventual evaporation and reprecipitation. That is nothing but the hydrological cycle. So basically hydrology, hydro means water. Okay, so hydrology is nothing but the study of the water in different states. Now the different states includes the study of water above the land. For example, like you can distribute into three parts: the study of water above the land, study of the water on the land, and study of the water below the land. Okay, so study of the water above the land is called as precipitation. Then study of the water, hydrology. Okay, study of water on the land surface is nothing but it is the surface or runoff water. And below the land, study of water below the land surface is called as groundwater or percolation. Okay, so hydrology is nothing but we're going to study the different forms of water above, on the land, and below the land surface. Okay, next is importance of hydrology. So hydrology has various aspects. Okay, so the first aspect include design of hydraulic structures. Now, structures such as bridges, dams, spillways, and all, they are in contact with water. So accurate predictions are necessary for their proper functioning. Due to a storm, the flow below a bridge has to be properly predicted. So improper prediction may cause failure of the complete structure. So, in order to stop this and disposing the excess of water into the dam, so the dam should be designed properly. Okay, otherwise the flooding occurs, and sometimes there will be the dam gets overtopped. Okay, so this is the importance. This is the first importance. Like we'll use the study of water, that is hydrology, for design of hydraulic structures like bridges and dams. Okay, so the next importance is municipal and industrial water supply. So now, growth of towns and cities are also industries. They are always dependent on the fresh water availability in their nearby place. So water should be drawn from rivers, streams, groundwater, etc. So proper estimation of water resources in order to use them, okay, eventually for various purposes, has to be planned and implemented. So it has to be planned properly and implemented for both domestic as well as industrial water supply. Okay, so the next important point is irrigation. Now, irrigation is nothing but when the dams are constructed, usually the dams are now constructed to store all the water. Whenever there is excess, the water gets stored there, and whenever there is a need, so the same water can be used for both domestic purposes and irrigation purposes. So now, for estimating the maximum storage capacity, uh, evaporation, and the other losses should also be properly estimated. So this can be done with proper understanding of hydrology for a given river basin, and thus making the irrigation project a successful one. So now artificial recharge will also increase the groundwater storage. So it can be estimated that groundwater potential, okay, can also be increased just by increasing the groundwater. Okay, so we don't have to only be dependent on rain as such. We can plan the water in such a way that it can be further it can be stored and further utilized whenever there is a need. Okay, so the next point is hydroelectric power generation. So a hydroelectric power plant needs continuous water supply. So, and there should not be too much of variation in the flow. So variations will affect the functioning of the turbines in the electric plants. Hence, proper estimation of river flow and also the flow which occurs and which help to construct efficient balancing reservoirs, and this will supply water to the turbines at a constant rate. So the flow should be at a constant rate, so that the continuous power generation will not be hampered. Okay. The next one is flood control in rivers. So controlling flood in the rivers is a complicated task. So the flow occurring due to a storm can be predicted if the catchment characteristics are properly known. In many cases, damages due to floods are high. So floodplain zones may be demarked to avoid losses. So we need to control the floods in the rivers. So proper planning should be done previously in order to uh, stop all this disasters, that is overflow, okay, overflow of or the floods. Okay, so the next point is navigation. So navigation is nothing but so main specifically the inland navigation. So in this, the depth of the water should be maintained at a constant level, and this can be achieved by providing proper gates and proper draft, that is extra length should be maintained. And if the river water contains sediments, they will settle in the channels and they cause the problem for navigations. So hence the catchment characteristic should be considered, and the sediment entry should not be allowed into the canals, because it reduces the canal storage capacity if the sediments are get settled at the bottom of the canals. And the last point is pollution control. So pollution control, it's an easy way to dispose sewage generated into the city or into the town, city and town into the. So usually most of the time we dispose everything into the streams and the rivers. So if large stream flows are available compared to the sewage discharge, the pollution problems do not rise as the sewage gets diluted and it starts flowing into the water, and the water has a self puring capacity. That is, lighter materials, they settle at the top, and the heavier sediments settle at the bottom. So the problem arises when each of the flows are not properly estimated. So in case of sewage flow, it is high, it should be treated before disposal into the river or the stream, or otherwise it will go and affect the streams and rivers. That is, it will try to pollute the streams and rivers. Okay, so the next is global water resources. So can you can see here, global water resources, the complete global water resources in terms of kilometers, out of which this is the fresh water, this is the salt water. You can see that fresh water is only 2.5% compared to salt water. Okay, so now this fresh water, it is in the form of glaciers. Okay, glaciers and permanent snow cover. So it is trapped in the snow mountains, okay, glaciers. Then groundwater is 30%, and rivers and lakes are just 0.3%. So it is very important to safeguard. It is very important to safeguard at least this 3%. How to safeguard this 3% is by keeping the lakes, nearby lakes and rivers, and there is um, these days there is a cleaning of rivers happening. So all the rivers and lakes should be maintained, because the only fresh water which we have to use, which we can use, is just 0.3%. Okay. All right. So again, this is the hydrological cycle. So it's a typical hydrological cycle. We have already studied this quite a few times. So hydrological cycle is nothing but, again, it is the precipitation. It's a cyclic process. So there is a precipitation here. So rain, it falls to the ground in the form of precipitation. You can see here, this is precipitation. Now because of this precipitation, it goes and flows over the land surface, mountainous land surface here. So, and it gets trapped into the trees, which is nothing but trees, that is the leaves, that is called as interception. And then it flows into the ground in the form of infiltration, and finally it percolates here. And once it enters the ground, so through the groundwater from a higher level to a lower level, it goes and flows into the ocean. So it flows through the aquifers as such, and this is a part of water. Then whatever precipitation nothing but it's the rainfall. So it flows on the surface in the form of runoff. Okay, and it goes and settles here in small ponds or lakes. And then it goes and sometimes it flows in the ocean also. Now this water, now whatever water flows, on the surface or which gets entrapped in the snow, and lakes, ponds, runoff, or from the ocean, again because of evaporation, so because of evaporation it again goes back and forms the cloud. Because of the sunlight it evaporates. So evaporates is nothing but, again, it is, evaporation is through so many factors. And they are, first is when it is falling to the ground, only a part of it gets evaporated. So it's evaporated when it is falling only. Then from the leaves from the trees it get interception, again from the interception again it gets evaporated. Then through transpiration, through the again stomata, through the leaves basically, it gets evaporated here. And then from the soil, so if the soil is quite moist, then water from that also gets evaporated. Then this is from water from the small streams and water bodies, again it's get evaporated here. And then from plants, because from plants they store water, it gets evaporated through plants. And finally major of which gets evaporated from the oceans. So again it forms the cloud here. Again these clouds, once the clouds are formed they condense there. So the water vapor gets condensed here through evaporation. Water gets condensed to vapor in the form of evaporation. Then again in this, once the cloud is formed, again water vapor get condensed to form the uh, water again, that is precipitation, and again it falls back to the ground. So this is the hydrological cycle. Okay, so if they ask you draw and explain the hydrological cycle, then you have to explain this. So it's a typical hydrological cycle. Okay, it's a typical hydrological cycle. But for you all, we have two more types. Now, this hydrological cycle is divided into two again. So, one is the qualitative representation of Horton's hydrological cycle. Okay, and one more is Horton's engineering representation. Okay, there are two here. Okay, so first one is, so basically again it is the same thing. So hydrological cycle, it is nothing but the circulation of water from sea to the land through the atmosphere. Okay, and back to the sea, often with the processes like again same thing: precipitation, interception, runoff, infiltration, percolation, groundwater, storage, evaporation, and transpiration. Okay. Now you can see here what we have studied previously, it is the same. So there is everything is same, but the representation is different. Okay. There used to always, in the previous slide, if you can see here, you have mentioned here what is mountains, and there is a ocean, groundwater, everything is, you have shown it here. But this is a different way. So this is the engineering, this is the qualitative representation. So it's a qualitative representation, and more specifically it's a Horton's, it's named after the person. So it is Horton's qualitative representation. So you're going to signify here how much is the um, measurement as such in terms of like percentage. So if it's like the circle, so measure of which is precipitation here. Okay, you can see it, this is complete precipitation, this is surface deposition of precipitation in all forms. So it's precipitation reaching the ground, the same thing what you have studied, but the representation is different here. You can see here there is infiltration, groundwater supply, surface runoff. Okay, there is atmospheric moisture, and finally you can see here there is evaporation and transpiration. So this is named after. So if they ask you ask you to draw this, then you have to draw this diagrams, that is qualitative representation of Horton's hydrological cycle. You have to draw this and explain as usual, what you have done before. The same thing. Okay. This is called as Horton's. Just a moment. Okay, so this is called as Horton's engineering representation. Okay, so engineering representation here is again same thing, but again here the representation is different. You can see here there are aquifers, oceans, and there are streams, lakes and rivers, soil, land surface, snowpacks, vegetation. Okay, so again same thing, from atmosphere the water gets precipitated here and it falls to the land, snowpacks, land, soil, aquifers. Then through this it will again rise. Okay, there is a interflow between these two, soil and the rivers. Then from the oceans directly it gets precipitated here. Sorry, it gets from the ocean, it comes down to the aquifers and ocean in the form of precipitation. Then it gets evaporated and from the oceans here, streams and lakes, and here from the land you can see here all these are precipitation and evaporation. So this bold line indicates precipitation and this indicates evaporation. Okay, so this again it is same, but again the representation is different. Okay. All right. So we'll continue the next topic in the next class. All right. That's all for today. Thank you.